So last 10 years of experience in data analytics and last 3 years of experience with our customers and product. I'm just going to share my experience and going to showcase a demo also so that everyone can understand how to create an AI at scale into it. Right? Okay, so this is the agenda for the day. Quick introduction about myself and the team, and little bit about AI. Everybody knows about AI, but we'll talk. It will be a conversation so that you don't sleep off. And challenges of AI at scale, solutions, and then two nice products that can enable AI at scale. And we'll go through a detailed demo. Probably we'll take a break before the demo and then hands-on and show you step-by-step process of creating an AI from scratch. Just solving a set of use cases. All right. So about my background. So last 10 years I have been implementing this large-scale big data analytics platforms for multiple industry verticals, multiple different companies ranging from telecom, finance, and e-commerce, especially Flipkart, right? So our core team of our company, Argoid, we are ex-Flipkart, and we built the data analytics platform of Flipkart, which is running and fuel. So Flipkart, and then based on our collective experiences of 5 people, all or 10 years of experience, we went and started this company called Sentienz, in Bangalore, wherein we work with customers, and fortunately we got big customers, top telecom provider in India, best shopping rewards app in US, and Fortune 200 healthcare company in the US. So fortunate enough to work with these companies and solve some of their problems using machine learning, AI. We also again involved with large data analysis end to end. Hence, today I'm going to just a little bit of share my knowledge on whatever we gathered so far with the experience. And during Sentienz times, right? Sentienz times, even though it's a big data product implementation, we were learning. It's a huge project to be built end to end. So over a period of 2.5 years, we built this product, company called Argoid. So Argoid is a Bay Area-based company, and it has specific focus in solving problems with respect to predicting consumer behavior. For example, Netflix and Amazon. You can understand your recommendations, personalized recommendations. Some of you, if I ask the questions to you, hey, how relevant is Netflix recommendation to you? Half of you will answer very relevant, and half of you will say not much relevant, right? Same goes with Amazon. So how can we enable all the other companies, right? These fan companies, Netflix, Facebook, Amazon, they can create such technology very easily, even though the volume of the complexities are very high. What about the other companies? Growing e-commerce company. They want to enable predictions, So that's the piece where Argoid helps solving. Giving recommendations as a service, hyper-personalized recommendations, next best offer, campaign effectiveness, and so on and so on. And pretty much solving similar problems in other industry verticals also, like IoT, machine predictive analytics, and then third one is financial BFSI vertical. So that's pretty much about our background on the team, and I'm glad to have our other team members here. Chakra, who is our CTO, and then Jay, who is our architect, data science lead in our team, and we are a pretty small team. We are located in Kolkata. So my business card is here, so you can get connected, talk, and exchange notes whenever we can after these sessions. So about AI. So what is AI? Anyone? So yeah,
I think that we expect humans to do.
Exactly. So good definition of AI is something like that. So I'll come to that a little later. So the thing is, back in 1900s, right, electricity powered the world, changed the way the world operates. It transformed the industries, starting from agriculture, manufacturing, everywhere. Today, AI is kind of powering the enterprises. Anybody, if you go and notice, everybody started their hands-on in AI and data science and machine learning. And the world is moving towards AI. And if I ask you to take a note and write down top 10 technology things which you will not live without, which did not exist 10 years before. So you will have a bunch of things in the list. And 10 years later, lot of that will be AI driven, around AI related products. That's where the world is going towards. And who knew AI would be solving problems in agriculture and cucumber? So, there is a short story. A guy, an engineer from Japan, his family background is they are farmers, cucumber farming. And his mom used to spend 8 hours per day on sorting out cucumbers. So cucumbers in Japan are sold in different varieties based on size, color, and based on the roughness. So his mom spent 8 hours per day, and he saw this open source framework called TensorFlow released by Google. Then he went and implemented the complete AI. He implemented cameras, it captured, and it kind of automated all those manual tasks his mom was doing, and he became an internet sensation. Overnight. The thing is, the message here is, it is not just some viral news spreading. It's like anybody can go and develop AI. A lot of open source tools are out there. So that's the kind of message the world should take away from that. And sorry, I switched to multiple slides. So yeah, we are here. So So AI is used in every industry, right? Doctors use it to diagnose cancer and treat cancer. Electrical companies use it to, optimize the amount of electricity being generated. Healthcare is used in wide varieties of areas. And going to the definition, as you said, right? This is the book definition of AI. It's when machine performs a task when human beings find industry useful and difficult to do. In our mind, right? Everybody, the media has hyped up what is AI. We all think like something in the movie science fiction, kind of Jarvis and Iron Man, or something like that. But in a nutshell, AI is just a set of algorithms. Algorithms are step-by-step instructions that something literal-minded like a computer can execute. Something like fire drill. What if some fire happens? There is a set of instructions. So very similarly, some set of instructions a computer can do. Thing is, when you cleverly tie all these different algorithms together, that becomes an AI, like Google Home. So before I came here, right, I asked my Google Home, hey, how long does it take to reach download from home? And there is an algorithm which converts my voice analog signal into digital signal. There is next algorithm which converts digital signal into English alphabets. Next one, the phonetics into exact words like long, all those different aspects. That is being posited to Google API, the Maps API, right? And that is a different pipeline, large pipeline altogether. It sends back the response. The response is being translated into a very verbal format, which a human can understand. Finally, some kind of phonetics is being applied so that it comes as a human voice, not like a robotic voice format. So multiple different algorithms involved in such a simple thing which we do day by day, right? So coming back to Moore's law. So everybody may have heard about Moore's law, right? So this is these are all a lot of buzzwords. But in simple terms, what does Moore's law mean? Moore's law means the overall processing power for computers will double every 2 years. So what does that mean? Example. So today I go and purchase a MacBook Air for 1 lakh rupees from market. So the processing speed of my MacBook Air is twice as much higher than last 1 to 2 years, and it is being growing like that every year, every 2 years. That's what is Moore's law. That means today it is calculating at a speed of 10 to the power 11 cycles per second. What that means? We'll do a little bit fast forward Moore's law. In 2023, it will be calculating 10 to the power of 16 cycles per second. It doesn't mean much to us, but it means a lot to the neuroscientist. If you go and ask a neuroscientist, what does that mean? The person will say that's the same kind of calculation a human brain can do. So that's the level of computation, like normal computer, and anybody can go and buy and they can apply. So what does it mean by me and to my business? You can ask. So in 2050, if I go and buy a MacBook Air for 1 lakh rupees, it's going to have a calculation speed of the entire human race, what we can do. So that's where the world is going towards. A lot of compute power is being out there. Now, a lot of data is also being collected, right? In the industries, everybody collects data. So what is the different typical usage? In any case, on How much data being collected is being used? Any random guess? Sorry? No, I mean the percentage of data being used. Let's say 100% data is being collected. Sorry? Yeah, you are almost accurate. So 73% of the data goes unused for analytics by the industries, and the data is being generated is 10 times more than that. Not all the data being generated is even collected first of all, and whatever is collected, only 32% of that is being used. So how do we unlock the potential of the data, the large volume of data out there? That's where we are going to go a little deep into the technologies from now. This slide on AI at scale. So some other statistics around the same points. So on an average, right, today where we are, you could say the average prediction accuracy we can get from the machine learning algorithms developed in the world could be around 50%, traditional means. And these are all different statistics published by the media. 9.7 million average financial impact for poor data in the businesses. And it takes a lot of time to build some large-scale insights platform from scratch. Why so? So these are the little bit deeper level challenges. The challenges can be broken down into two parts. Well, how to listen honey for me? If you spell correctly, I probably bet something on it. If 5 people, if we try spelling Kaudu Bisnahali, we will make it wrong. There are a lot of bad data being collected by the system. How come for an e-commerce company, the system should know exactly the latitude, longitude of location so that it can optimize the last mile delivery. So these are all critical business problems. The data is not accurate. That's another problem. And misaligned data. So this is another case where in a typical enterprise, there are multiple teams managing different databases, data sources. There is some change happening in one system. The same change, it takes a lot of time for the other system to propagate. There is a misalignment in the data. So how do you handle that? And missing data. This is another interesting example for one of our customers, right? They gave all their data to us, and they asked to run campaigns, based on the gender, male or female. You run different campaigns for the people. But the funny fact was the gender data was captured only for the 50% of the data set. So rest 50, no data captured. How do you run a campaign? What if I show a random makeup ad to a man? So it can result in a churn. So those are the problems around data typically happening in the enterprises today. And talking about the machine learning challenges. First thing is feature detection. So feature detection is nothing but identifying features in the data that can cause a particular prediction. For example, customer churn. Customer churn is nothing but customer leaving a particular company. So for identifying churn, right, what are the different reasons the data scientist with domain knowledge creates features? These are the different reasons the person might leave, the competitor experience, the feedback, the delivery speed. All different attributes are combined together by the data scientist. But in a production scenario, it's not as simple as that. There can be 100 reasons why a person may leave. How a data scientist can find all the factors with thousands of columns and billions of rows? It's impossible to do that, right? Because of that, we could apply only basic linear algorithms. What I mean by that is, we can apply basic linear algorithms when there is an output like 0 or 1. When we can draw a line on a graph, there is a 0 or 1. But the space here is non-linear. There are 1,000 different reasons why a person can churn. So we cannot apply just basic linear algorithms. And the results become black box because data scientists, trial and error basis, tries and different things. And finally, when you ask or when you want to reuse some particular whatever been implemented so far, it's very difficult to do that. Everything is black box. Everything is tied into a person's head. And that's why we get that 50% accuracy overall. That's why, reason for why average 50% accuracy everywhere. Now, ideally, how we can solve this? The ideal way to solve it is put hard engineering efforts and create real-time systems in place so that first of all, data being collected gets entered into the system and gets stored. Second thing, accurate data. I could say some examples, right? That Kaudu Bisnahali. So all those different qualities in the data, we fixed it using machine learning again. So, the amount of persons entered that address correctly, if 90% of people referring to Adugasnahali with the specific spelling, we made it correct, using machine learning. We tuned that. That's how we could be able to correct the data. So there are a number of ways to do that, statistical methods. The thing is, we have to have systems in place so that we can make the changes fast and deploy them. And the data has to be calibrated, out of order data. One system sends one data piece, the other system doesn't send it. We have to have systems in place to manage those kind of capabilities. And as I said, the gender data was missing, right? For men and women. However, we fixed it by predicting the gender based on the purchase behavior, overall purchase behavior. So we could get 98% accuracy, very easy to find. Even though there could be some kind of errors and precision loss, but still the overall accuracy was very good. And that's how we could help our customer run effective campaigns. And second thing, the feature detection, I said, right? How a data scientist can see all the patterns in data. It's impossible for, in a production scenario, to see thousands of attributes and identify all the patterns, 1,000 different reasons why a person can leave. However, AI can do that. So it's kind of, we are saying the AI can build AI. The AI itself can identify the features in the data depending on the use cases. That's the whole topic about today, auto ML part, right? I'll talk detail, about later, even with the examples. And when AI does that, right, when one person cannot look at 1,000, attribute data with billion rows, but 1,000 AIs can do parallelly. Humans are very good at detecting patterns in a very small volume of data. For this volume of data, when AI does that, right, it need not apply a linear algorithm. It can apply a complex, sophisticated ensemble. So ensemble is a combination of algorithms suited for a particular prediction, particular use case. Then, since everything is done automated way, things become explainable. Results are explainable. No more black box. Everything is reusable. We can fix issues. We can debug issues. That's how we can get to greater accuracies. 90% plus accuracy, whatever accuracy we want. That's the kind of innovation we have to put and finally build an AI. So far, I'll just take a break and if there are any questions, we can go through.
That AI can develop AI. This is like similar to the cross-validation, what happens in a model selection, the parameter tuning happens in cross-validation. If we extend that conceptually, then you would lead to that kind of AI developing AI.
Exactly, that's the exact same thing I'm talking about. So, companies like Datarobot, X2 AI, a lot of different open Google Auto ML, Amazon SageMaker. So they do exact same things. They do automatic feature detection, hyperparameter tuning, a bunch of other things, applying different algorithms and validating the results, and what kind of metrics to see for a particular prediction. It's not like accuracy and precision only works for everything. There are different ways of measuring different algorithm results. So all these are being automated collectively, and hence saving a lot of time being spent by data scientists. We'll come detail into that later in the coming slides.
So one question.
Yeah.
You said enriched data is very important for doing as to increase the accuracy.
Yes.
And most of the times when we are making such products or maybe doing some data mining or something like that, we are in the POC stage and we don't have the data, right? So we don't have customer data. So either we build some demo data or we collect some data from internet and we try to do that. And when customer comes and sees the product and sees what model we have built, they directly reject it, saying that this is not the correct business domain, that knowledge that they have and what you have modeled. So how do you have any suggestions for that?
Yes, sure. So we also faced the exact same problems initially, right? When you talk to a customer, you have to talk from the same point of view of customer. So what we have chosen is Kaggle, right? Kaggle have tons of data. So for showing a demo to a banking customer, there is a Santander Bank data problem available, predictive customer product recommendation. There were 10 million rows. So, and then there was telecom data, and there was e-commerce data, churn data. Even today, the demo I'm going to show is taken from Kaggle, churn data. So that's how we took the data and we put it through a pipeline and showed the solution to the customer. So that's one of the ways. Maybe probably other things we can talk maybe offline later. Any other questions?
What is calibration of data?
So calibrating is something like, from, let's say, there are customer price of a product is being calculated by two different systems. Let's say there is a supply chain system is calculating based on all different transportation costs and etc. And there is another system which is calculating with the different other factors. Ideally, these two should match. But they are different. So how do I identify which is relevant? It's not something like this is right or this is wrong. Based on the context, we have to choose the right data. So the system has to understand that and make that suggestion on the particular choice on the fly, real time. So that's what I was trying to say. Based on the context, again, all this majority of these optimizations I said that can be solved by machine learning, if not by traditional rule-based business logics. Okay. So this is another dimension of seeing the problems, this is the only way to run AI at scale. Typical enterprise scenario, right? Data is scattered into multiple data sources: MySQL, MongoDB, Oracle, and multiple teams are managing them. In a typical production scenario, right? In an enterprise or in a startup also, there is a customer. Let's take a small example, an e-commerce startup, and customer feedback is coming through a different channel. Customer product reviews are coming from a different channel, and products are coming from a different channel. So first of all, you have to aggregate this data into one common place and make sure any change happens in the source system. Let's say today you are capturing 5 different attributes of customer click. Tomorrow you are capturing hover, when he hovers through the product. You want to make more predictions, more accurate value add to the customer. So how does the system adapt to those changes? You have to ensure those are in place. And it's very complex to build that from scratch. It takes years. Then data is all aggregated to one place. Okay, data lake or whatever we call different terminologies. Then what happens next? Thing is, depending on the use case, we have to combine the data. For example, customer and product and customer feedback, data should be merged together and cleansed, enriched for predicting customer churn. For product recommendation, it's different set of data. Different set of data being picked and chosen. Everything should be automated. Only then we can get to this, predicting at scale, right? And we should have capabilities to do that. Then comes the modeling layer, right? Again, once we have the processed data, modeling requires very clean and processed data. So majority of the work, 80% of the work being done by data scientists today are in cleaning the data rather than analyzing the data. So all those should be taken care before it comes to the modeling layer. Highly clean, processed, enriched data. Even then, once it reaches there, the data volume is huge. Creating an accurate model is very, very complex. That's where we are now, on an overall scenario. And finally, the consumption layer. How do you deploy a model? How do you run a model, train it, and make sure it is adapting to the changes that is happening? During Big Billion days, Indian customers may behave differently than all other days, festival days. So how a model can understand the dynamic behavioral change of customers? For example, during demonetization, there was complete change, chaos happening in all different consumer-facing industries. So how an algorithm can predict at scale and do this? So we will talk more about this in detail. Okay, so I'll explain and we will show a detailed demo also about Streamsets. So data ingestion challenges. First one. So what are the challenges? The data is huge, right? It comes with these 3 famous challenges. There are 3V problem, 5V problem, 10V problem. Majorly it is 3V. Volume. The data is very, very huge being collected. Velocity. It is not just huge, it is coming at a really high speed. And variety. As I said, it is coming from different channels, different sources with different formats. So how do you aggregate all this data together in one place, make sure it is adapting to the changes happening in the source systems, and not disturbing any of the other flows. And finally, you are able to visualize any problems. Any problem happens, how do you ensure it is getting fixed? So business critical issues, right? If you are missing out on fraud detection for 1 hour, you are losing out a lot of opportunities. As a company, losing a lot of revenue. So you name a database: Oracle, MongoDB, HDFS, Kafka, Salesforce database, Amazon store, or Google Cloud Store. It has support so that any person within the ecosystem, data scientist, analyst, engineer, they don't need to write any code to get data from one place. All they need to do is just write a pipeline. So instead of spending months and weeks of effort, it is done in minutes, extracting data from one place to another place. And the kind of the product is in a commercial format as well. The good news is the piece of the code, which is like extracting data, the connectors code, and all this UI and main functionalities are open source. You can go and find Streamsets data collector, you can download and you can play around. I'll show you in the demo exactly how it works. How do you get data from multiple places, create and play around with the pipelines. And that is the main features that Streamsets provides. And that's the main thing which is unlocking a lot of potential, the data collection piece. Any company you go and ask, right, first of all, they will say, there are a lot of data out there, but I don't know what data I have. And I don't know how to make use of it. And if you go talk to anybody, if anybody says, hey, I need 2 years time, 1 year time to find what data you have, nobody pays interest. That's why data is in siloed mode. So these kind of tools accelerate that. It enables getting the data very quickly and start using it from day one. So it provides these 3 major functionalities. The first one is the automation part. As I said, 50 plus connectors for source, 50 plus connectors for destination are available. Okay. So, second is the drift. So, what is drift? Drift is the change in the structure of the data, right? The schema of the data. As I said, for now we are collecting 5 different attributes from a click stream of a customer from an e-commerce website. Let's say we have to add one more field or change something else on the underlying schema, remove some field or change the format. Today it is in integer, tomorrow you are changing to string. So how do you ensure all the other systems take this schema change dynamically and adapt it at real time, right? One real world example is, even in large companies, let's say new business line, fashion. Let's say fashion was not there, they are releasing it today. But for the data analytics or insights team to catch to the pace of the business, it takes 6 months to 1 year. The main reasons being all these kind of challenges, adapting to the changes in the data, building systems from scratch again and going over the same cycle again. Streamsets kind of tackles those challenges by automatically handling the schema drift on the fly for multiple data destinations. Any change happens here, it knows, hey, this row is this column is modified, I'm going to fix this, the destination system, without even anybody going and intervening, doing anything manually.
Sorry, I have a doubt.
Yes.
So that data sources like MongoDB or Kafka, what you mentioned, these are the repositories and the JSON and those things like Python has pickle. So those are the streams. So it's just if you can clarify. So how these are connected basically?
Yeah. So let's say I collect customer geo-demographical information, profile information from MongoDB. And today I have 5 different attributes of customer being collected. Name, age, location. And I missed another information like married or not. And let's say I have another source which can tell whether the person is married or not. And I'm adding to my MongoDB. Now how does let's say I'm storing the data to Kafka. Or another example, Kafka maybe not apt here. Let's say I'm storing it in Hadoop, HDFS, Hive basically. So how, without manual intervention, the system will automatically add that particular column, populate that column for the new data being coming in, without affecting the existing data out there. So when anyone fires a query, Hive query, right, they don't stuck at compilation error or anything like that. The thing is that the schema drift is being taken care automatically by the system. It can be multiple different things, backward compatibility changes, non-backward compatible changes, forward compatible, and so all different kind of scenarios are being taken care by the system.
So drift is a tool or is it?
It's a concept. So these 3 things, which is the main features of Streamsets: automation, drift, and monitoring, which I'm going to talk about. So again, traditionally, let's say as a company, I have 10 different data sources about customers and products and everything, and I have to integrate into one place. So what I will do, I will go to open source, find Golden Gate if I want to get data from Oracle, and Scoop if I want to get data from Hadoop. Likewise, I can create a lot of different connectors, that's over a period of time. And what if I have to monitor this all at one place? Because as a business, I care about the reports and predictions, whatever is being generated. And what if something goes wrong? How do I understand? So Streamsets provides a unified interface from where You can monitor. Data is coming from any system, it goes to any system. It shows you record by record what is the statistics. How many records came in, how many records went, how many records are set to error stream. All this monitoring is in place so that in case of any issue, we can fix it immediately. So this is a snapshot of the Streamsets console. I'll show you in the demo, exactly what each layer means. So this is a sample pipeline we created for we're getting data from a Kafka and then splitting into 5 different Kafka topics, writing into another cluster. And based on the field in the data, so the data has a type. What is the type of the stream data being coming in? It can be customer, account, transaction, or card or loan. This is a kind of a banking use case. And I'm storing it in 5 different Kafka topics, which will be further consumed by other downstream applications. So now we are going to the AutoML part. Now we talked about cleansing the data, processing the data, integrating at scale, handling changes at scale. All good. Now we have clean, processed, large data with tons of patterns. Now how do we build effective models from that? So this is again the statistics I told you, right? Data preparation accounts for about 80% of the workload of data scientists. This doesn't mean whatever cleanup we have done so far. Domain-specific knowledge is required to engineer features. What can affect the prediction? What are the different kind of aggregations I can make on this data? So where does it come from? Those are kind of lot of manual tasks being done by data scientists and trial and error, applying this algorithm, that algorithm, seeing whether this works or not. And that work is being called data. I'm not making this up. Go to Wikipedia and type data janitor. It gives you this, who is a data janitor person? Who takes big data and condenses it to clean and process the data. So it's not hype, this is a fact. Data scientists are majorly being employed as data janitors, and this is doesn't make sense anymore, right? So where should we move towards is creating effective models, make whatever tools out there and solve business use cases quickly. So that's when the AutoML comes to the rescue. So what does AutoML means? So all these manual tasks done by data scientists, right? I'm not saying 100%. Still data scientist comes in with some kind of a domain knowledge, but the redundant and complex and irritating tasks, which AI can solve. That's why AI exists. Redundant, complex tasks, time-consuming tasks done by human, that can be automated. So exactly, hyperparameter optimization. I'll go detail by detailing and I'm focusing Datarobot. So Datarobot is a company, pioneer in AutoML. They claim, but they're one among the best. We also use Datarobot on a day-to-day basis, and we realize the benefits from Datarobot, day-to-day. So here is where exactly it tells what all can be automated in creating a model. So first one is the extracting of features, transforming raw data into features that will act as input for a model. For example, some cases your data can be in text format. You want to convert it into numericals, do some encoding for a specific algorithm. So all that kind of data preparation can be automated. And splitting the data set into multiple different sets for a different purpose. For example, model is being generated, how do you validate it? So input data is being separated to test data, and then not for model training you use some other different data. That is chosen automatically, and it is not chosen randomly. Based on some statistical methods, it is being taken into consideration. Then determining the model evaluation criteria. So different models are measured differently. Gradient boost, or linear regression, logistic regression, or classification. Not everything is measured by accuracy or precision, or all these different aspects. There can be different metrics available, and everything lies in the data scientist. I'm not saying it is irrelevant. It is relevant, but these are all redundant things which can be automated. Then the training of the models. This is where the amazing features of AutoML kicks in place. Datarobot have thousands of models, and when you submit a sample data to their API, they are in a combination of these models parallelly in a distributed mode. 10 workers, 100 workers, 1000 workers. It can run and it can tell you and show in a leaderboard. These model combination, this ensemble performed well, this performed best. So this is what you have to use it for your business. This model is created, within some minutes or even for a large set of data for hours, rather than traditionally it would take even months. But the accuracy can be again, a tricky question here. And model outcomes, analysis of model outcomes by we can since all this is done automatically by AI, it can discover new insights from the model training itself, and it can show in the dashboard. I'll show you to all different metrics, as part of the demo. And finally, deploying the model. Model is created, all right. So how do we deploy this? How do I use it? It should be very easy and seamless. With the click of a button, I should be able to deploy a model. For example, churn prediction or segmenting customers for running campaigns. So how do you do that? How does the system do that? So model deployment also should be taken care so that ideally it should be a microservice or a REST-based implementation. Any application can come and consume it. For example, Netflix, how it does the recommendations for a person. Dynamically, when a person loads the screen, it goes into the API, dynamically it hits the model till this minute what the person has watched and what this person is going to watch next. So that's the kind of framework we should have end-to-end from data preparation to model deployment. A lot of things can be automated. I'll show you with real examples how it works. So that's the Datarobot piece, and this is what they say. What they really mean. So data science requires math and stats, aptitude, programming skills, business knowledge. With Datarobot, you bring the business knowledge and data, and cutting edge automation takes care of the rest, the other pieces. Yeah.
So suppose on Amazon there's a new user. So how do you collect the data on what he's referring to, what kind of products he's trying to buy? So that's like whole stack problem in a recommendation system. So how do you avoid for that for new users?
So let's say I, as a person, I have a certain taste. Based on my purchase behavior, this is how I perform for a period of time. I like electronics, I like all different gaming products. And if a new user comes, and he has the same journey he's following, he's kind of buying the products, electronic products. And from that I can match both of us, even though I don't know about the history of you, I know the history of other persons who is like you very much, with a confidence of 90% match. Based on that I can predict and give that particular recommendation to the person. That's one of the ways we can do that. So, it's just like a Google Photos, right? Imagine how Google Photos work. It uses tag ones or Facebook photos, like your name, Gokul, I'm tagging ones. What it does, it goes to all my photos, it groups it automatically. I don't say, this is my childhood photo, this is where my photo was taken in a low light. Everywhere it captures, it's all using deep learning neural networks and finds it automatically, right? So, similar way, what I was saying is, there is one person whose complete journey as a company knows. This person came in at this time, he got so and so products, and it categorizes a person into this person is fond of electronics, lives in Pune area, and all the other characteristics are found automatically by the machine learning algorithm. And now another person comes and he follows same path, similar customer journey, and it can match both the people and provide recommendation to this person, which this person already like. That's the same funda how Netflix works or Amazon recommendation system works.
Sir, could you please elaborate more on automatic feature extraction? As in the example that you just gave, where you convert date of birth into age, is it something that you feed, or is it that the model learns itself, or whatever Datarobot learns itself that converting date of birth into age might actually be?
So, yeah, what Datarobot does is, your data can have missing values. So, based on the other available values, it applies some statistical methods and refills those things. And it creates some aggregate counts. If you have some classified columns, how many number of users churned from this region. So it creates all those extra attributes also that, and then for each algorithm, right? For example, for some certain algorithms use one-hot encoding. Not everybody requires that. So it knows for what algorithm requires what kind of data, and it does that automatically. I'll show you with the flow how it does that automatically. So this is what they say they do end-to-end, Datarobot's auto-assembly. So model optimization, data pre-processing, feature engineering, variable type detection, encoding. I mean, I'm not going into details of this, but we will visualize what really is in the demo. And all these aspects are already talked about: the parallel processing, deployment, and SDK. It also provides a software package for any person to query the API. Whatever the model we built, right, gives some prediction, recommendation. So how do you get the data, real output from the model, right? It gives you some sample piece of code where from your application you can call that and get the insights at real time. So Datarobot is a commercial application; it's not free, and so there are a lot of other open source machine learning auto applications available frameworks. Like Pen AI is developed by Pennsylvania University, and Microsoft released the neural networks intelligence. That's kind of a deep learning. So for each different things, there are different auto frameworks available. And Transform, Drift by Salesforce. Finally, AutoKeras for again deep learning, running auto on deep learning. So yeah, close to 3. So any other questions? Then we can take a tea break. Then we can gather and go through the demo completely. Questions?
The previous tool you said was Streamsets.
Yeah,
Is that also paid?
that's for running at a lower volume. Let's say you are running in one node, it is free, but it doesn't have the features like monitoring, multiple nodes. That is not free, but you can go and try it out. Or it also supports running Spark, which is essentially another open source which can run parallel computing systems. Right? So that is possible. Streamsets is part. You can say whatever we need to run a POC or show a demo, it's free. And there is lot of other open source frameworks similar to Streamsets available, like Apache MyFi. So that's the equal, very similar to Streamsets. The main difference is MyFi, the way it's architected, right? It's high performant system, but it's not user friendly. That's why it hasn't reached the state of what Streamsets is. As a backend system is completely robust, highly scalable, efficient, but UI.
Business problems which I'm trying to resolve, but when my business problem is not actually covered as a Excel, or even it doesn't come under a division or convolution unit, it's on a graph. So I need to learn from a graph of data and come up with my own learning. That is the business problem I'm trying to resolve.
So we also solve similar problems, like grouping customer segments using.
Yeah, but the problem is the data I'm getting, it's from a graph in a graph way. So it's like a triple stores where subject predicate. There is a relationship between two nodes. From one node, I need to understand the relationship with multiple nodes, like multiple layers, not its immediate nodes, but multiple layers.
It's a taxonomy.
Exactly. Taxonomy, ontology.
Yeah.
So depending upon that, I need to predict something about that particular node. So in that phenomena, I was looking for AutoML from GCP or AWS SageMaker, but they always need one supervised data or the data which is already trained for them to train. And my problem is that I don't have it. So that is the business problem which we are trying to resolve.
So we also have used similar set of frameworks for solving specific problems using this graph database taxonomy.
They have
calculating the results. So we didn't use it in maybe the same kind of scenario as yours, but let's say you are extracting unstructured data from for a customer, right? Like a state can be TN. TN can mean different things.
Okay.
So we have a knowledge graph
Exactly.
about cities and all these hierarchically formatted.
Okay.
So you can go and find what are the related attributes, and it knows I'm talking about a state. So it figures that out and validates that its TN is a state, Tamil Nadu, and then
Okay,
This
so
is what
what kind of algorithms or what kind of, you have any apps for doing it or?
okay, yeah. I'll link the exact people. Yeah.
So there is standard data available for such things?
For
Like,
yeah, we condense the Wikipedia data,
oh,
the knowledge graph.
you have created your own.
Complete Wikipedia we condensed into one machine. Full complete knowledge graph. Wikipedia is available, DBpedia is available.
There are a lot of other metrics, right? How does somebody how will the algorithm give results? What
Error metric. In the sense,
like there are different ways to measure the accuracy.
Mhm.
How will the algorithm give the result for one particular?
it gives you confusion matrix and accuracy.
There's a standard set.
Standard sets. It doesn't have anything. So the thing is, it's using all the standard set of metrics available, standard set of algorithms, but it is automatic. It is not has put any IP around the metrics as person.
So is your company sells this product?
Yeah, Argoid is a product as well.
Available as a service or
Available as a service cloud, we can deploy it in cloud, we can deploy it on-premise also. So right now we are implementing this for alpha customers in all three segments.
you tell us about the pricing?
So pricing is based on the number of entities we track. So 100,000 monthly active customers. That's main measure. There are multiple variables available, but main is the value is being generated by the number of customers we track. And in terms of IoT cases, number of devices, just the entities being tracked and the value provided. So different tier-based pricing, 100,000 till million customers. So we are having a telecom data set. Data set about customers, call history, records, and voicemail, account information, subscription information. And we are going to predict customer churn, whether this customer will churn or not, based on all the different factors of historical reasons why people leave, with the bad customer experience or whatever it is. And sorry,
Is it public data set?
it's public data set. Probably I can give the link also. Later. And this is the pipeline we are going to run through, the data pipeline. So we are having the source data set in a MySQL database. There are 5 different source data sets. So I'll explain what it is. And we are taking the data from MySQL from 5 different data sets, and we are streaming to Kafka in 5 different topics. And there is another job called the Goblin, which picks up the data from Kafka and loads it into HDFS periodically. Then, all the 5 different streams, right? We have another job which aggregates this data for churn. So what are the attributes I have to aggregate from this data? Plus, it also does the feature engineering, like what are the total calls this person has been, made over the last 1 year, or monthly, different other aggregate attributes. That is being loaded into MySQL, a different processed data. Finally, we're using Datarobot. We will be able to take the data from MySQL, build a model on the fly, and then we will be getting the predictions from the Datarobot using a different mechanism. Again, another command line, which I will show you. This is the whole story about the demo. Yeah. So the processing job takes 5 different streams of data, combines them together. Account, call history, voicemail, subscription plan, customer info, merges them, and it computes the features like total calls made, total calls dropped, total customer service calls made. From the data, it figures out those columns, adds them. Yeah. Then, I mean, it's both data processing means aggregation plus feature engineering. That process data is loaded into MySQL. Then, finally, we will be showing the prediction also. You know. So in this example, we are defining the features, but it can be built on its own also. That there's another demo version available where we can showcase that. Probably next time.
So the feature engineering happens before Datarobot.
Some steps of feature engineering. Datarobot also some certain feature engineering tasks. So domain specific, we have it here. So for this John use case, these are the set of attributes required. That's what we compute. Domain specific attributes. Datarobot does the mathematical stuff. Mean, median, average.
Datarobot can also be used for feature engineering.
Right. So let's put it these two ways. Domain specific, we have to do separately. Common Datarobot tools, mean, median, average, or calculating missing values, all those different aspects.
Domain values depend like the behaviors of what are my expectations kind of a thing. I need to train myself.
Yes, I'll show you the exact column names, what are our computer. Yeah, we will be able to relate. So let's go to MySQL and understand the source data. So accounts table, call history, customers, plans, subscription, voicemail history. Thing is, in a production scenario, this will be lying in different databases altogether, different formats. I'll quickly show you how the data looks like in each of the tables. So accounts table has customer ID and ID, phone number, registered state. It has a lot of columns, so a lot of rows. I think close to 1 million rows is what we will ingest, in the Streamsets total. And call history, certain attributes. It has a subscription ID, accounts, duration, and the area code. So these are all these other details. This customer service call, other person is calling the customer service, this international event time, all the attributes about the call history. Then customers have the information like customer demographical information, name, age, location, all the other details, and the plans regarding what are the different types of plans available. I'll quickly show you. If you feel you can skip this metadata definition, you can skip it. What I will do is, I have created a pipeline. So this is the Argoid. We call it command center dashboard. End-to-end, we can visualize what's happening. So we use Streamsets here in the ingestion layer, and Datarobot in the models layer, and we have our own, IP there, connecting all these pieces together. So we'll go to ingestion and see how a pipeline looks like. This is the Streamsets console. So it shows you different pipelines in this console, all different pipelines. A pipeline means it takes data from a source, it does some enrichment or processing of the data, and then streams the data to n number of destinations. It may not be one-to-one mapping, it may be one-to-one meaning, but source should be always one. When a pipeline cannot get data from multiple sources. So this specific demo, there is a pipeline called customer data stream. So you are able to see this first piece, right? This is the source. This is where the data comes from. So when you want to create a new pipeline, it will list you 100 different sources available. I will quickly show you. create a new pipeline, test pipeline. Select origin. So you can see the different sources available, connectors. So you don't need to write any code for connecting to these data sources. Everything is available. We just need to specify the endpoints, where it is deployed, IP or other different endpoint details. And once you do that, it has a lot of processors. You know, what is the transformation that should be applied on the data? How do I write it? Which language? JavaScript, Java. It supports 5 different languages and the specific library functions. For example, JSON data is coming in a hierarchical format. You want to flatten it, or you want to remove some fields in the data, change the names. For all this, you don't need to write code again. You can use these library functions. You can specify what is the field you want to remove, what is the exact thing you need to do. You don't need to say how it should be done. That's taken care of by the libraries as well. And one additional thing, what we have done is in Argoid, we have added this AI agents that can process the data automatically, which prepares the data for the data scientist. You know, we have some domain-specific AI agents sitting there. For example, converting customer addresses, unstructured address to structured format, getting the exact door number, street, and all this other information, and enriching information from city, computing different attributes, latitude, longitude, states, country, other information, and for retail-specific scenarios, you know, identifying the categories of the product. Given you know, Nike shoe, identifying it is, you know, in fashion, 5 different levels where it belongs to. For other downstream processing, for
the whole summary of this is basically you're going to predict if the customer is going to leave.
yes.
Yeah. But this is data which is historical data already with you, not a live streaming data which is coming, from which you predict after a few months this guy could leave. Like that.
So the thing is, consider this scenario. You have a historical data, and the reasons, I mean, the results. These were the churn, people who churned. That's what we are depicting here. But it answers both ways. Thing is, once we build and deploy, then whatever data comes in, it automatically takes.
Our data pipeline knows how, as soon as the database new records are entered, it automatically takes it, or you wait for some time and then you.
It automatically takes. It has the capability to connect to the system. As in when a new record comes in, it takes it real time. Yes.
So, is there any direct connection to streaming data instead of taking from database?
Yes. It supports REST API also. You can create an endpoint, REST endpoint here, expose it. Anybody can stream the data to this, rather than it pulls the data from another device.
Okay.
Should it be like
It depends. Yes. Periodic.
Oh, this system is a streaming, real-time streaming.
My question was like when a new record has come, you have predicted the behavior.
Yeah.
But would that record to be periodically updated?
By the time the customer will leave, what to predict before he leaves.
So the thing is, you know, let's say we have a historical data. We built a model today. Today it works with a precision, 90% accuracy. But tomorrow it may change. How are we going to adapt to the changes? What your question is, right? So there are, again, as I talked offline to multiple folks here, right? There can be 2 setups. One,
This doesn't have MQTT connector as a subscriber.
we can connect the other one as I mentioned, the transporter layer.
Transport is there.
Yes. But we'll take it offline that piece. But you know, so the thing is, today we built a model with accuracy 90%, and it is giving me results, which person is churning or not. What if the behavioral change happens in the data?
How does it autocorrect it?
How does it autocorrect? So one of the solutions I'm suggesting, we can have an inference model which is in production, catering to the real data. Whatever data comes in, customer data, it processes, cleanses, and it gives to the model. The model will tell you it's churn or not. And second thing, there's a training model. It's a different setup, and it is also using real data and it is correcting itself. Thing is, you can compare the scores of these two, put it automated, and replace the model whenever you reach a certain threshold. Let's say it reaches 80% accuracy, other model is outperforming this, you can correct it. It is, and based on my experience, for stock market predictions, it can happen very frequently. per day. But for any other consumer behavioral use case, once in 6 months or even once in a month is when this could be done. It may not be that much kind of real-time automated. But yeah.
The model you are
Yes.
describing right now does have that feature environment.
Yeah, our framework has that. We can use some kind of similar
How
setup.
often is this model replaced, you say? Frequency of replacement?
I mean, it's configurable. It's up to you when you want to replace it. That's all.
So in stock market prediction, how fast is this?
Yeah, stock market prediction.
Right?
Day.
Every day.
Yeah, every day probably.
You're finding the model every day.
The thing is, some news happens. Every day some new data points are coming, new things are coming, right?
Because you have not taken the features into account for the new. I don't know. There can be endless number of features.
I think what you mentioned is the stock market is something which is more dynamic. Other areas are data.
Stock market is.
Customer behavior, something is said that it might change in a month or 2 weeks.
Yeah, that is much easier. The stock market is.
Yeah.
You don't know what is causing it.
Yeah, I mean, just an example. Yeah. Sure.
If you succeeded in stock market, then nothing else.
Yeah. Like stock market and weather, it can never be solved.
Weather is still, it's much more predictable.
I mean, yeah. We'll see.
You can have anomalies once in a way sometimes. Stock market you can't predict.
I agree with the point. For comparison sake, I mentioned these things. So going back to that piece which we discussed, right? The customer data which we are getting from these 5 tables. This is the pipeline which does that. It takes data from the MySQL database, and we are doing some operations on the data, as you can see here. Renaming some fields coming from the data, flattening the fields. I'll show you the logic also quickly, but screen is somewhere else.
Currently, where is your model hosted?
Currently,
Where is this model hosted?
these are all from AWS. I mean, I'm accessing this from AWS.
So you ask deployment customer.
Where is this?
This demo, where is it hosted? This services. So, rename build on fields. We can see how we are renaming the build on fields. Source is type. We are renaming it to build underscore. Some kind of examples to showcase the transformation capabilities. Add lineage. So, thing is, data flows from multiple systems. So, it's better to capture the kind of metadata stamping where it is right now, where it came from, in order for further downstream analysis or debugging anything from the line, and removing unwanted things, and finally storing it in Kafka. So what I'm going to do is I'm running this pipeline to run this pipeline. It's going to stream those records instantly. We can visualize the metric record by record how it is streaming. Then we can go and check in Kafka how the data looks like now. Are those new fields which we added came in, the lineage fields, renamed fields. So I'm running the pipeline, and you're able to visualize the statistics here, right? Live statistics, right? It's streaming the records here. So as it streams, there are million records to be streamed, and it is one node being deployed. If you want to stream faster, you can add more nodes, it will deploy faster. Now I will show you in Kafka how the data looks like. The first entry point here from Streamsets is going to Kafka. So going to command line. So each table is being streamed as it is. I mean, we are not yet combining the data. So call history is coming as telecom underscore call history in the in Kafka. So yeah, sure. So as you see, the data is a JSON file. I just tailed 2 records. I'll put it in another better viewer and show you.
Any specific reason for using Kafka?
for high throughput ingestion. So Hadoop is write speed is very poor. So not accommodate high throughput ingestion. That's what it's being used. So this is how the transform data looks like. It's not showing here, but hope you can see a little bit. I mean, okay, not much visible, but here I'll show you. Duration, whatever the input messages is coming as a form of a JSON here, and now the raw types are renamed into bin log underscore. Some of the fields which we renamed, and the lineage also is added. As you see, source type is MySQL. This is what we are adding inside the Streamsets. Timestamp of processed record and source details, etc. Now, likewise, there are 5 different topics available so far. Now, what happens? As I said, for high throughput ingestion support, we are streaming into Kafka. Now, from Kafka, there is another job. There is an open source framework called Gokul. It's open sourced by LinkedIn. So that takes data from Kafka periodically and puts it into HDFS, Hadoop system. So that's what is being described here. Goblin takes and loads it into HDFS. I'll show you how it looks in HDFS as a file now. So HDFS, all the historical record is being stored. That's why even if you send billion records, right, Kafka can take some so and so, but all the historical records are being stored in HDFS and horizontally scalable. You can store as much as you want. And I'll show you quickly HDFS, how it looks like. All history.
What is the buffer size in the Kafka?
Typically, in production, we could keep 2 weeks. Yes. Depending on the all the SLAs. So this is one of the files which this is just now being written. So I'm going to tail and show you quickly how the data looks in HDFS also. So data came to HDFS.
So by the time it reaches your model, you are already 2 weeks late.
No. The thing is, the retention period is 2 weeks, but things are happening in real time. Thing is, if anything wrong happens in this job or downstream, anything wrong happens, you can still go back to the timeline for 2 weeks, maximum 2 weeks. That's the kind of cache we have for Kafka. But actual data processing is happening in real time. So right now I showed you, right? Data came here immediately to HDFS. It doesn't wait for so much time.
And why are we able to Kafka for 2 weeks?
So as I said, SLAs, it can be 2 weeks or 2 days. That's the kind of a time machine. Something bad happens downstream, maximum 2 weeks back you can go back. It can be 2 weeks, 2 months, or even 2 days. Doesn't matter. I'm saying in my experience, for all our production scenarios, we have kept it to 2 weeks.
There's no disaster recovery at the HDFS side.
We could have from both sides, from HDFS side, from Kafka side also. So now the processing job comes into picture. There's the processing layer wherein we configure the jobs. Churn data flattener DB is the job being configured. This is Python script which takes the data from HDFS, combines them, and adds those extra columns, and loads it back to MySQL. So I'll run this job now. It's being triggered, and the data will be loaded soon there. So what we can do is, I'll go to MySQL and check. It's from a different database. Which is processing.churn data. So in the input data, right, we don't see account name. This is being computed by this job. And total day calls, day minutes, day charge. All these total columns are computed. These are the features, extra features needed for this use case. Total international charge, customer calls, and the is churn. Is churn is also historical field that is given in the data itself.
Based on study from the other columns.
Yeah. So derivative of the other columns of the data. And right now the process data, cleansed and processed, everything is ready now for creating effective models. So we are in the modeling layer now. Now how do we create a model from here? So yeah.
Feature engineering, does it draw the additional columns which is more correlation, those kind of advanced engineering does it do? Let's say I have an ID column, it's not required for me.
Yes.
Does it draw that column like that?
So in this case we did. Now we wrote a job which did computed additional columns and dropped additional columns. I mean it's not automated. I mean in the sense of it's not something like Datarobot does. This is some kind of a business level inputs which engineering we have to do explicitly. Python script. So it can be Python script, it can be Spark job. So that's the thing, processing layer support multiple jobs here. Spark, Hive, Druid, or a simple Python script. So for large processing, you can use distributed frameworks to process the data. And creating a model, so we'll go to the AutoML part now, the Datarobot. Yes, here it is. So this is the Datarobot console. I'm going to create a new project and connect it to my SQL. So it's taking the processed data now and then uploading, and it will do first EDA, the exploratory data analysis. Basically, it adds some new columns and fills in. We'll be able to see what additional things it has done. Then we can trigger a button and run it in autopilot mode, saying that, hey, Datarobot, generate a model for me. This is the data for you, and this is my target variable. So in this case, input data had a variable called is churn, right? So I want to predict churn from the data. So all I'm going to say is, this churn is the one I want to predict, and immediately it's giving me number of rows. This churn is there, 0 and 1 current statistics. So I do start. For that, I'll show you the data also, how it came here. It will be showing you the data with all values. And see, it added these fields, unique, missing.
It does this for everything or is?
Yeah, it does this for it.
Inferred that these are the things required for it.
It does.
The fields which it generated, by default it generates for every kind of data?
Yes.
Or only for this specific case it generated these fields?
It generates these
Same for
for any kind of data. Then onwards, when it does that, applies different algorithms, right? Each algorithm needs a different input. I'll show you when it does that. It does that also extra.
Which are the additional fields it does at the start?
These ones, unique,
Okay.
missing, mean, standard deviation, median, min, max. And raw features, informative features.
Missing means what?
Missing data. Input data did not have any value for that. So, for let's say you stream 1000 records and 900 records had values, 100 did not have. So what it does is it does applies some statistics to compute those missing records, again using some mathematical operations for it to predict accurately. It won't leave those 10 records, 100 records. It will include them, but it will add some heuristics to it. Now I'll run it. Click start.
Like he asked like will it look for all kinds of data or every data. But this it would be your business algorithm which would have defined it. This is the feature or that domain feature. These things you would have added. That's why
We gave just the data, right? Input calls, records, total number of calls customer made, all this. It only added for each column, total day minutes. Unique values are 2068. This particular column. Missing is 0. It's not nowhere missing. Median of that. This additional columns it computes for any data. It's not domain specific at all. So you can visualize, right? It is running already algorithms and going to increase the workers to 10. So it is now trying all different combination of machine learning algorithms. It takes around 10 minutes here, 5 to 10 minutes.
It's running in your CPU or?
It's cloud.
Cloud.
Yeah.
Processing is happening in cloud.
Yeah, Datarobot's cloud. We can configure the workers, number of workers in here. And I'll show you the previous run output while it runs. Once it runs, we will see after 10 minutes how does the output look like.
Sir, until how is it doing so fast?
Sorry?
I was wondering how is it doing so fast?
Yeah. So yeah, that's why it's running many things and it shows you leaderboard. I'll show you the leaderboard. Churn prediction from DB. This is the previous run which we made. Same data. And models page shows the leaderboard. The thing is, Datarobot is built by Kaggle data scientists. People who initially participated in Kaggle. Kaggle is an online data science competition platform. These guys created a tool so that they win the competition. All the time they spend in writing code and all this. Then they realized this problem exists for everybody, data scientists in the world. That's when they made a company and now it's grown this far. So again, that's why they show the leaderboard. How each algorithm perform, how the combination of algorithms performed in the output here. So here you can see this specific algorithm is what it says recommended for deployment. And different metrics, validation, cross-validation, holdout. I'll click and show you other details around that. But if you scroll down, you can see what all it did. It did not just apply one algorithm in this case. Here's advanced AVG blender. It applied a combination of models. So we can show you. So it did extreme gradient boosted reclassifier, gradient, and it applied multiple other.
How is it doing the final selection?
Final selection of?
The model, what is the recommended model?
Yeah, recommended model. It does based on some parameters like accuracy, precision, and all the other variables.
It's not defined.
No, it only suggests. We don't define that. So we can choose. It's not like we have to go only with the top recommended model for that. But in this case, our takeaway is not accuracy. See, out of 100 customers, if 10 are churning, if the algorithm says 100 are churning, accuracy will be like 90%, 95%. That's what I need. That's not what I need. I need a precision, true precision. Out of 100 customers, out of 15 customers who are churning, at least you should take 13% are churning and rest all are not churning. That's the kind of precision I need. It's a precision score we need here. So I'll show you the metric and relate exactly to that. You can, it gives you.
In this app, like when before I train my model, can I say somewhere configure that this is my parameters of.
I think we can do that. So the thing is, we done the autopilot, right?
Okay.
If there is a manual mode where you can do all those additional configuration and tuning.
So based on that, it takes the.
Yes. So this is the example where the ensembles, where I mentioned like machine learning ensembles are being produced here. So here we will the greedy trees classifier. This is the model it created and it's in the top. So I'll show you the results, what it gave. This is the model blueprint, how it looks like, what it did. From the data, it categorized the variables into categorical variables and numerical variables. And for categorical variables, right, classified variables, it did one-hot encoding and these three different processing.
Is it trying both categorical and numerical? What does it mean? It's branching.
So from the data, it took the categorical variables and doing one-hot encoding for this particular algorithm, right? This model. Finally, when it comes here, the gradient boosted greedy trace classifier, it needs the classified variables in one-hot encoded format. That's what it does. Subset of data it does.
And another way is taking the continuous variable.
Yes.
Will you drop any features just implement that?
Dropping features.
Will you take all the features?
That Chakra.
So for each model, it will try to apply different set of things. So if you have to put extra features, so Datarobot itself generally will suggest like, okay, so based on certain correlation metrics and stuff, so it will only suggest, okay, out of these 20 features, these are the recommended ones. You can create a new set of features like, okay, use only these 10 features out of 20 features and then all the models. Okay, general autocorrect. For each model, it will only try all different combinations of features and then it will choose the best features. So whatever best set of features it will decide and then it will take it. So will it also be a combination of features? Like for one model, it may use even say for an external model, I'm using 3 different models, right? Or say model 1, model 3 and model 2. So model 1, model 2 and model 3. These are the 3 models used for a particular example. And for model 1, you will use the 10 features and model 2 you will use 12 features. So since it's in the background, it tries running with all different possible combinations and then figure out okay, output the best metrics, which set of features is really needed for this particular model. I mean the interaction features. Okay, for example, I have a variable for x, I can take it to 1 x square. So that is an option. You can only create a new feature mentioning like the column. I have a column A. To create a column B equal to A square or some expression you can give, which will automatically take that. But will it suggest interactions like so for these kind of things in Datarobot don't do. General things like okay, you create one of the feature as a A, right? Then automatically it will only give like a day of week, day of month. So say A. So that level of feature engineering does. But this kind of customized one, it provides an interface to allow us to make a component.
But you can do that yourself, in the first stage itself. When you're extracting the data, that time you can add another column for what you want.
Yeah, so that also we can add. So in this case,
That stage itself you can add what are the feature you want to add. Pre-processing itself you can add the feature you want to add. But after you predict this person is going to leave, how do I get out to the root cause analysis? For what reason has you predicted this person is going to leave for this reason? Because you've got so many features. So how do you find the root cause?
So it gives the feature impact.
Each feature impact is also including?
Yeah. Yeah. So I'm going to see this. Here it is product customer service call and these are the top 4 5 attributes from where you derive the prediction.
Is algorithm dependent or algorithm independent? How does it calculate this code?
That's what. How did it calculate this is a particular? Suppose it has picked up a DL model or something. Then how do you know which feature has caused this problem?
So there is a specific library available.
Sorry?
Yeah, so there is a specific library available which we can apply for a model to derive this feature.
After you have predicted this person is leaving, and he has selected a DL. So okay, or neural network is related, you do not know which feature has caused this model to predict this, or what is the root cause of it. Here you are showing it as this.
This is the feature impact for this particular model.
This particular model.
This particular model maybe.
Yeah.
Yeah, this. I'm showing a specific model here.
Okay.
The first model, gradient posted greedy trees classifier. This model performed with it gives prediction only because of these features. And this is the relevance for each of the features. This is the explanation we are asking for, right?
But suppose you could have selected some other model, you could have said.
Yeah, actually a different one.
Can you take a zoom in related to different feature in that model? No, but that there are multiple nodes or the networks in the network. You don't know which one has caused.
In each hidden layer, you consider each row. So each row, all the parameters you train. So that becomes one prediction. So because you have considered all the data points of a single row. So his question is, which particular column of that row is impacting this?
This doesn't use DL actually, deep learning at all. This doesn't use deep learning at all.
This doesn't use it all.
Doesn't use. So it's machine learning.
So there is no solution that you can actually do something for the shaft. These are shafty values that you find out across rows. So once you have done this, once you get each other, which is important, after that you can learn something for a shafty values.
It's real how to do that.
We are going to do.
This one,
This
data row, I don't tell you.
No, it doesn't.
Each row is very important. I don't think it will tell you.
Only by examples. It doesn't go to.
Sorry?
It does only machine learning ensemble models. Doesn't go to DL level.
It doesn't select.
I really don't know deep learning.
Yes.
It doesn't select that one.
It doesn't use deep learning at all.
It doesn't use deep. This doesn't use deep learning.
It's not a neural network.
It's not. It doesn't use.
Why don't you need a DNN for this case? You don't need it.
No, I'm saying it depends on the case. What you're
If
saying.
you use DL, will you be able to do a feature impact?
No,
You are asking in data robot specific or in general?
in general. But you're saying Datarobot doesn't select DL at all.
Yeah.
I mean, is there maths behind why every feature, basically you are able to generate as code, right? In case you have logistic regression, you can do hypothesis testing and basically figure out what feature or what variable creates more impact. Is there some sort of that stuff, or like is there also some machine learning behind calculating these codes?
So I think the accuracy that came in is actually considering the importance of this feature. When you see the top feature that says some customer service calls, so this feature has been impacting the algorithm.
Yeah, but how do you get that basically? Suppose you have a random variable.
It's entropy if you know that. Yeah. So basically what they do is they see each feature. If you just remove that feature and make a model over it, you see the impact. And then you include that feature and then you run the model and then you see the impact and take the difference of that and then they get a score over it.
They do some correlation analysis with the different combination of features. Whichever is yielding a good result, they potentially find that the importance of this feature might be good.
In which one?
I mean, the algorithm you selected, this is
Okay, this one.
yeah. Same applies to neural networks as well.
Same way you do that.
Yeah.
You remove the feature.
Model will do something like this.
Sorry?
Even in neural networks, you can do something and you can calculate it. It's not specific to any learning. You can calculate feature important for each of any of the learnings.
But neurals, I mean, it's not. When it becomes complex, right? How do you define the hidden layers and correlate with that? That's, I mean, the different topics, maybe we can focus later.
I just want to take a step back and understand the business side of things.
Yes, sure.
So, for example, how many calls do you input data of customers who have left, or is it a combination of
So input data, historical data, these are the attributes, and these are the customers who left.
Who left?
Complete data set is there.
So obviously, customer who left before leaving, they will make lot of service calls. So
that's being correlated here.
that is. So do we need such a complicated algorithm to derive this?
This is an example case, but that's why in production I said, right, there will be hundreds and thousands of attributes. So in that case, that's where it gives the upper hand. So for demo purpose, I didn't complicate much. Just set of rows and set of columns. That's it.
Is there any limit on the number of features that you can?
Yeah. So there is a limit. Kind of rows and columns wise, there is a limit on the data size wise. That's why we do different ways of tackling it. For example, dimensional detection. We do that out of the Datarobot, and we do also set reduction. Set reduction in the sense, let's say billion rows are there. You pick and choose million rows that represent all billion rows. That's the example I'm throwing. But in essence, we will be able to represent a small set of data that represents whole data.
And how do you do that?
Learning. Yes. Everybody is looking, so if please no any referral, please forward. Yeah, it'll be great.
So this product of yours uses these two other products,
Yeah.
and it has created the whole
Solution, yeah, around that.
solution.
Exactly.
So nobody else has done this or similar.
We haven't come across. There are companies who are using Streamsets separately, but the same combination we haven't come across yet. Probably there may be there little bit, but yeah, we haven't come across yet.
What else is there? I mean, apart from these two. So if my other alternative is to just get these two products and use it, right? So what else is missing or what else have you built on top?
So yeah, as I said, we built a solution on top of that. In the sense, these the tools. The thing is, our team is all contributor to these open source components, Hadoop, Kafka, HBase, and everything. So the end-to-end ecosystem. Anything wrong happens, it's a solution, right? That is one aspect. All the deployables, containerized server running, scalable in the cloud, auto scale up, scale down, plus the optimization side. So, tool, right? When you have large data, how do you just without sharding instead of taking top 100 rows and creating a model, choose the relevant rows. That's again, some kind of IP is being built there, and AI-based cleaning and enrichment. I didn't go detail into that, but customer data, what are the kind of different cleansing and enrichment you can do? And we also built some NLP engines which can take unstructured customer feedback data, convert to structured, add relevance to the prediction. It's a complete solution around that. Using this technology and building some solution around. Same goes with IoT also, machine data.
Any voice processing is there?
Sorry?
Voice processing?
No, voice we don't have yet. But we have some tie-up with some companies. So NLP takes unstructured text data to structured data.
Now the model which you built, at this stage, it has just trained the model.
Yeah. Train and it is deployed also in data. I'll show you.
So deployed is have you given an input of data which has to be predicted?
Yeah, I'll show you. So these are the statistics about the top model which performed, right? So as I said, this is a confusion matrix. So true positive is actual churn which predicted to be true. And true negative is not churn and predicted to be false, which is both numbers are looking very good. And the other two are okay. There are a little bit of some error. So this is the best performing model here. And you can go to predict here in Datarobot, and there is this deploy model API. you can import the test data here and test it here itself, or you can get the API and call it from your underlying applications. The deployed model can be used. So here, I'll also show an example. So this is the code it is asking you to call from your application. API token, project ID, and model ID, and other little bit piece of code to get the output. So I'll show you. I'll run this from a machine and with the test data. It's different from the trained data, and I'll show the output now. So I have put it into the script, and this is the test file I'm sending with the API key and the model ID and other details. So that output it gave for each customer, churn or not churn. For the test data. So this is how we finally use it in the applications. Typically, marketing campaigns, any system can use this model which is deployed and then do some action around it, say run some relevant